In this question, we given that f of x is equal to x square plus n for x less than 0, nx plus m if x is in between 0 and 1, nx square plus m if x is greater than 1, and limit x tends to 0 fx exists, limit x tends to 1 fx also exists. If that is so, you are asked to find the values of m and n. So first let us consider this information. So limit x tends to 0 fx exists. That means the right limit has to be equal to the left limit. So limit x tends to 0 plus fx. So in the right neighborhood of 0, that is slightly greater than 0, the function is nx plus m, right? This has to be equal to limit x tends to 0 minus. In the left neighborhood of 0, the limit is, the function is x square plus m. So this implies, so what is x tends to 0 and x plus m? Just do the direct substitution. 0 plus m is equal to x tends to 0 again m. So m is equal to m. That's the first information. So similarly, let us do the limit x tends to 1. So limit x tends to 1 plus fx. So within the positive neighborhood of 1, that is greater than 1, the function is nx square plus m. Has to be equal to limit x tends to 1 minus. Limit x tends to 1 minus. We have nx plus m. Nx plus m. So this implies, as x tends to 1, the right limit is n plus m. As x tends to 1, the left limit is n plus m. So m plus n is equal to n plus 1. N plus m is equal to n plus m is an identity. That is, this is always true. And if both the conditions have to be valid, then the second condition is always true. The first condition is true as long as m is equal to n. So effectively, if these two conditions have to be satisfied, then m has to be equal to n. Then m is equal to n is the condition. That means you don't need to have specific values for m and n. So as long as m is equal to n, this function is such that the limit x tends to 0 and x tends to 1 exists.